Okay, so we are starting the lab. It's week 3, and we'll be working with Xcode. Again, we've been talking during the lecture about more features of the language, right? We've been, again, talking more about functions, been talking a little bit about classes, access control, things like that, extensions as well, right? So what we want to do today, we want to practice a little bit more. And the next week, we'll have our first lab test. Yeah, I see you're happy about that. That's good. So let's start. Let's create a new playground. And lab 3. Make sure that we can see something on this screen, right? So I will change the font to something bigger than what it is right now. Better? Okay. I posted some examples, the questions that you can get on the lab test on Blackboard. So let's take a look at them. First one is simple. You have a, actually, let's go to Blackboard. Here it is. So we have the first function there. And this is the function that we want to create. The function is called write backwards. The idea here is to get the integer that has 4 digits, and you have to write them backwards without using string. With string, it's easy, right? You create a string based on the integer, you reverse the string using the string functions, and you convert it back to the integer, right? No brainer. Right? Here I want to use, I don't want you to use string. I want you to use division, and I want you to use modulo. Any ideas how to do it? Something like C language, which we divided the main number into the digit. I don't remember it was 10, or I don't remember exactly. And the reminder will be yeah. You're on the right track, right? The number that you're dividing by depends on it depends on the digit that you want to extract, right? You have, you write it as a comment, right? If you have 1, 2, 3, 4, right? How do you explain that to your kids? You don't have kids. That's the problem, right? You say, okay, the 1 in this notation means that this is 1 times 1,000, right? And then we are adding 2 times, right? 2 times 100. And then we are adding 3 times 10. And then you're adding 4 times 1, right? So if I want to reverse the digits, what do I have to do? Yeah, the thing that was multiplied by 1 right now has to be multiplied by 10. Sorry, by 1,000, right? We are swapping the numbers, right? So we have our number, right? The number is n. Let's define the variables that we need. Now we can create a variable like d1, d2, d3, d4 for each digit, right? We don't need to do that. We can have a digit, Let's say it will be 0 right now. We need another reminder that will be our another variable that will be our reminder. Let's set, right now it will be n, right? It will be exactly the number that we have. And then we need another variable that will be our result. And it will be 0 as well. And we'll return the result at the end. So what do we have to do? As you said, we have to take our reminder or our initial number. It's the same thing right now, right? Reminder. And we have to divide it by the position, right? By 1,000. I'm extracting the first number, the first digit. And in the result, that will be the last one, right? So I know that result is exactly like that. Result equals reminder divided by 1,000, right? Now, my reminder will be equal to reminder modulo 1,000. This is what is left, right? So this is 2, 3, 4. Next step, result plus equal reminder divided by 100. Reminder rem modulo 100, right? And then result plus equal reminder divided by 10. And reminder equal reminder modulo 10. And then result plus equal reminder is what I'm sorry, what is left, right? Correct? Can we do it in a simpler way? Can we do it in a simpler way? Less code. Maybe with a loop. Because this will work, right? Let's test. Before we start modifying this code, let's test it. What is the name of the function? Right, backwards. One, two, three, four. Ten. If it's really 10, that means that we made a mistake somewhere. It is 10. So what is wrong with our code? Let's debug. Let's look at the code that we have and think. Result is 0. We divide it by 1,000. is 1. Of course. Times I have to reverse, right? So this will be times 10. This one will be times 100. And this one will be times 1000. Right? That makes more sense. Is this is extracting the first digit. That will be the last digit in the output, right? This is the second digit, right? And this will be the second digit, second last digit in the output, right? Third digit will be the second digit in the output, and the fourth digit will be the first one in the output, right? So we are multiplying it by different values, right? Here is really multiplication by 1, right? If we follow exactly the notation that we had, here, right? Now my question is, can we do it shorter? Can we do it maybe with some loop? Any idea? Can we do it in more universal way? Sorry? We can run a loop starting from backwards and when it ends 0. You're right. What he's saying, we can start extracting from the last digit, right? So instead of, we are using the knowledge that we have prior, right? We have information that this is always the 4-digit number, right? What if we don't have this knowledge? Then we don't know what should we use here, right? What should be the initial divider, right? And you're saying we can start from the backwards, right? From the last digit. How do we extract the last digit? So let's do this. Let's leave this function as it is, and let's define a new function. Let's call it any, right? Write any backwards. For sure, we'll have some variable result, and we'll return this variable at the end, right? Return result. What we were saying is, let's call it D. We can extract the last digit, and the last digit really is n modulo 10. Right? This is our last digit. What do we do next? The last digit should be multiplied. So right now we can say result equals D, right? Equals the digit. And then we'll need some loop, right? Because we cannot work with n, we cannot say n equals something, right? We cannot say n equals n modulo 10 or n divided by 10, because n is not an in-out parameter. We will need the variable, right? Var number. Number. And we'll be performing this action as long as number is more than 0, right? We'll be performing the same steps. We'll be performing the same steps, but in each step, we'll be saying that result should be times equal 10, right? We're pushing the number higher, and then we need to calculate new digit, right? Digit is equal to number modulo 10 result plus equal digit, right? And number is equal to number divided by 10. Make sense? In each step, we are pushing the numbers farther, and we are extracting the new digit, adding it to the result, right? So it's on the proper place. And then we are cutting this number off, right, from the digit off from the number that we are processing. Let's test. Okay. I'm not sure if it's running or not. Let's restart this. Not sure why it's not allowing me to set the breakpoint, but I can do this. Let's see if this is the function that is causing a problem. Sorry? No, that doesn't matter. Is it working in your? Yeah. Okay. In my case, it's thinking on it. But you see the idea, right? And with this kind of function, you can have any integer, right? If it will be 1 digit, we'll just do this and break, right? Will be 5 digits, we'll just another loop iteration. Yeah. Anything that you can squeeze into an int. Okay. The next thing that we want to practice. The next one is simple, right? Printing or returning a sum of integers from 0 to n. No brainer, right? This kind of function can have variations, right? So for example, write me a function that returns the sum of all integers from 0 to 1 that are odd or even or divide by 3. Let's take a look at the third one, the bouncy sequence. Okay, still thinking. Bouncy sequence, bouncy ball sequence is based on a fairly simple idea. You drop the ball. We have actually a picture on the board for this one. You drop the ball from specified height, right? You get this information about the height as a parameter, right? This is your initial height. And you know how bouncy is the ball, right? The bounce coefficient gives you the information of how much of the initial height the ball will get back after bouncing, right? So let's say it's 1/2, right, or 4.5. I'm dropping the ball from here, goes down, bounces back, but only to half of the height, right? And each time the height will be lower and lower and lower, right? Depending on the coefficient. If the coefficient is closer to 1, you will have more bouncy ball, right? So you have more bounces. If it's closer to 0, you have something that is totally not bouncy, right? The question here is how many times the ball will bounce if you drop it from a given height, if it has a given coefficient. How you would do this. What should I do? What should I do? Poor me. It's a lab test and I have this question. How do I approach that? There is no gravity. We have just the coefficient and the initial height. We are not taking gravity into account. Obviously, there is gravity because the ball is going always down, right? We can do it with recursion.
You just need to return I multiplied by the height multiplied by the coefficient that is given.
So I can do it with recursion, as you said, or I can do it with sorry, with iteration. The idea is in both cases the same, right? My next height is the current one times coefficient, right? So if I want to do it with iteration, I would need a variable. I'll call it h. And it's the height, right? This is the element that I got. I also know that I should stop my calculation when height is less than 0.1. So as long as height is more than that, I'll be doing my loop, right? In this case, we also know that our how many should be increased by 1, right? We dropped the ball, it just did flop on the floor, 1, right? And we can say that this is times bounce coefficient, right? So that's our first iteration right away. If h is less than this, we stop, right? If not, we say that how many will be plus equal 1, right? We are adding 1 to our calculation. And we are saying that h times equal bounce coefficient. That's with iteration. Let's see if it works. We are saying that for bouncy ball, this this should print 22. Let's see. Oh, it's bouncy ball sequence. $22. And if the ball is less bouncy, you have lower numbers. If it's more bouncy, you have bigger numbers, right? You said that we can do it with instead of iteration, we can use recursion. How would you do that?
Which is if I is less than 0.01, you would put 0, and then you 1. Next.
Exactly. Right. So instead of doing the while loop, we are saying that if height is less than 0.1, then we return what? It doesn't count, right? So we return 0. Else, we return 1 plus bouncy ball sequence. The coefficient is the same, right? So it's bounce coefficient. And the height is height times bounce coefficient. We don't need this. It's giving us the same result, so we can assume it's working. Which one do you prefer? Sorry?
You don't really need else. Because you don't really need the else.
Yeah, that's true. There is no other option, right? I could write it like that. If I didn't return from the if statement, then I should go into the recursion. Any preferences? Which version do you prefer? Which one is easier? Which one is easier to understand and to write?
First one.
The first one with iteration?
More straightforward to read. Recursion, you need to kind of go through it and then eventually.
It's, you know what, with this, it's a personal preference, really. Whatever suits you best, right? They're equivalent. You can do it in both ways, and in both ways it's correct, right? This is less, the first version is definitely less memory consuming, right? Recursive one requires extra memory because you're copying those.
Not really. You start things like that and saving into cache. Like sort of cache. It takes faster than just loop iteration. So in some cases, right?
Yeah. That's why we are looking at both of them, right? So you can compare, you can pick one, you can do tests, right? So you won't see much difference in terms of runtime with simple cases like that.
Yeah, if it goes to like figures input recursion with like that.
No, it also depends on the amount of work that you do in the loop and in the function, right? Because that really makes the difference. The amount of work that you need to do, and also the size of the parameters that you're passing, because you're copying them, right? Okay, what else? The last one is also simple. Take a look at the last specification. Again, I will get rid of this. I'll let you do this one yourself. you have a function that is providing you with an estimate. You're telling that the half marathon for the runner took certain number of minutes, and you're asking about the time that the same runner will need for the full marathon, to double the length, and also you're giving a Boolean flag that is saying if the marathon path is hilly or not, right? If the marathon is not hilly, then we are saying that the runner, our estimate is double the time for the half marathon plus 10 minutes. If it's hilly, then we are saying that it's double the time for the marathon plus 20 minutes. Can you do that yourself? Right, so this so this function is quite simple, right? It's basically one branch with adding proper constant. Okay. Another thing, we've been talking about functions that can return more than one value, right? So basically, we've been talking about tuples. Let's say we want to create a function that will calculate stats for array. And it will be an array of integers, right? I want to calculate at the same time minimum and maximum. We can add more stats to this, but let's keep it simple. Let's say I want to calculate only minimum and maximum. What should I return from this function? What's this? What is this? What is this construct? How it's called? Huh? No, it's not a dictionary. It's a tuple. So what we are passing as a parameter is an array of integers, right? But what we return is a tuple, right? And this tuple is labeled how do we calculate minimum and maximum? We'll do a loop, right? So I will create two variables, current, min. I'm assuming that it is sitting in the first cell, right? That's my approach. Current, max, is the same. I'm looking at the first number, right? And I'm saying, okay, so this is my current minimum and current maximum. I don't know what is sitting in other places, right? And then I'll use for statement, right? I will say that value in array, right, for each of them. And actually, in this case, I want to look only at the numbers that are farther than the first field, right? If value is less than current minimum, my current minimum will be equal to value, right? And if value is more than current maximum, I will update my current max. This is the end of my loop. And I can create a return statement with current mean and current max. Quite simple linear search, no assumptions about the array. Now what I can do with this, I can save it, right? Var p is equal to this. What is it complaining about? What is the problem? Let's do the following. If array dot count is more than 1, we want to do this. And in here, we'll check if array is empty, and we'll return 2 zeros. Now it should work. Now if we give the empty array 0 and 0, if we give array with 1 element, it is also correct answer, right? So in any case, when you want to return more than 1 value from your function, you should use tuple. Also, if the tuple, like in this case, the tuple is labeled, you can access elements from the tuple in two ways. You can use a dot notation, or you can use array notation. Sorry, not array notation, but no, it should work like that. Not array, but dot 0 and dot 1. Right, so you can use either labels or the position in a tuple, but with a dot notation. Also, we've been talking about functions, and we said that we can return functions as results, and we can take functions as parameters. Let's take a look quickly at this first case. So we want to create a function. We want to create a function that will return another function. So I will have a function. I will call it choose step. This function will take a flag. A Boolean flag. By default, the value of this flag will be false and will return an interesting thing. Because we'll return a function that takes an integer and returns an integer. We'll define this two functions. We'll have two functions, obviously, right? We have a Boolean switch, right? So we'll need two functions. One will be called step forward, input int returns int, and it will be defined as a simple return statement. Input plus 1. The second one, you also defined here, and as you can guess, it will be step backward, and we'll be deducting 1, right? Now, our return statement for the actual function will be like that. We'll check if backward is true, right? If it's true, then we'll return step backward. Else step forward. So I have two definitions, right? Two functions defined here. And I'm returning one depending on the parameter, right? So now I can define a variable step, and I can choose the step based on my based on the parameter, right? If I say true, it will be backward true. What I can do with this, I can use the function. You can see that depending on the parameter here, my behavior of the step changes. You can use the same concept, defining a parameter of the function that is a function, right? So you can say, I want a function foo that will take another function, and this function will take an integer and return a Boolean. And this function will be a void function. And now I can call f. I can say something like that. Okay. Now I can define a function test that takes an integer and returns Boolean. And there will be an if statement, right? If n is more than 100, actually, I don't have to write an if statement. I can simply write return this, right? That's my test function, and I can call foo test. Missing argument level. Oh. See the idea? So this way you can create different kinds of comparators, different kinds of operators, and apply them to multiple elements. For example, building a map statements, right? Do you have any questions? No questions? Okay, so what I will do, I will stop the recording now. Where is it? Here it is. I'm stopping the recording right now.